Welcome to the Unit 3, Section 4 video on transformations of linear functions. A family of functions is a set of functions whose graphs have basic characteristics in common. All linear functions form a family because all their graphs are the same basic shape, which is a line. So a parent function is the most basic function in a family. For a linear function, the parent function is y equals x, or in function notation, f of x equals x. Because you can't get any more basic than a slope of 1 and a y-intercept of 0. A change in position or size of a graph is called the transformation. A linear function can be transformed in three ways. It can either have a translation, which is a transformation that moves every point the same distance in the same direction. A rotation, which is a transformation about a point. Or a reflection, which is a transformation across a line that produces a mirror image. So a vertical translation of a linear function is when the y-intercept b is changed in the function f of x equals mx plus b. The graph is translated vertically. If b increases, the graph is translated up. If b decreases, the graph is translated down. So in this example, we have our parent function in the solid line and our translated function in the dashed line. Our translated function has x plus 4, so we've added 4 to x, which has caused it to translate up 4 units. In this example, we have a translated function of x minus 4. The minus 4 behind the x has translated the function down 4 units. A rotation of a linear function is when the slope m is changed in the function f of x equals mx plus b. It causes a rotation of the graph about the point 0b, which changes the line's steepness. So here, our rotated function, which is indicated by the dashed line, is y equals 2x. Our slope is steeper because our rise over run is 2 over 1. And we have rotated counterclockwise about the point 0, 0, which is our y-intercept. In this one, our rotated function is 1/2 x. So since our value for slope has gone below 1, we have become less steep, and we have rotated clockwise about the point 0, 0. The reflection of a linear function is when the slope m is multiplied by -1, causing the graph to reflect across the y-axis. So in this case, our reflected function is y equals -x. That caused a reflection across the y-axis. Here we have a reflected function. Again, the only change is the slope has become negative, which has also caused a reflection across the y-axis. Recall that a parent function is the simplest function with the defining characteristics of the family. The linear parent function is f of x equals x. Any linear function with a different slope and or y-intercept is simply a transformation of this parent function. We have already discussed that a linear function can be translated up and down, rotated, and or reflected. We will use a more general form of the linear equation to describe these transformations. This will allow us to explore transformations left and right and how to describe the rotations. So we're going to start with our more generalized form of the linear equation. So we have an a out in the front that gets multiplied by the quantity x minus h. So we can take some value and either add or subtract it from the x, and that is our h value. And then we also have on the very end plus k. And each of the three variables, a, h, and k, are going to perform some sort of transformation. So let's start with our h value. We have a horizontal translation to the right if our h value is positive. So for example, it will look like this. Within the parentheses, you'll have x minus 5. We simply put a positive value in for h. Right now, no a and no k. A horizontal translation to the left occurs when h is negative. And so if we put in a negative 5, you have minus a negative, which makes it x plus 5. So be careful when you're talking about horizontal translations to the left and right, because when you're encountering an equation, it's going to look like right is negative and left is positive simply because h in the general form at the top there follows a minus sign. So it's going to look opposite of how you would think it should go. A vertical translation up is when k is positive, so that k on the end is when it's positive, so you'll have something like x plus 5. A vertical translation down occurs when k is negative, so something like x minus 5. Notice this time, no parentheses. So you may ask yourself, well, isn't a translation to the left and a translation up the same thing because both are x plus 5, and the same for right and down because both are x minus 5? And you would be correct. We're going to talk a little about that in the next slide here, but a translation to the left is the same as a translation up because a linear function is so simplistic. A translation up is the same as left, and we can say the same for down and right. A translation going down is the same as a translation going to the right. So that's h and k. The last 4 boxes are for a because the sign of a tells us something and the value for a tells us something. So let's start with the sign of a. You have a reflection across the x-axis when a is negative. So if we have a negative x, like you see here. Now, what about a reflection across the y-axis? That occurs when the negative sign is in front of x. Now you may say, well, isn't it in front of x in the previous one? Well, it is, but this time it has to be in front of x within the parentheses. If you go back to our form there, x is inside the parentheses, so it needs to be within the parentheses. And you're going to ask yourself, isn't the same thing? Well, yes, an x-axis reflection and y-axis reflection are the same thing for a linear function. When we get to more complicated functions, a reflection across the x and the y are two different things. Now we have the value for a. You have a vertical stretch when the value for a, so when we're not looking at the sign, just the number, is greater than 1. So something like 2x. We have a vertical compression if a is between 0 and 1. So you can think of the value being less than 1, but we're not dealing with the negatives here, so it will be greater than 0. So you have something like 1/2 x. Because a linear function is simplistic, make note of the following. We've already mentioned a few of these, but I want to bring them up one more time. A horizontal translation right is the same as a vertical translation down. A horizontal translation to the left is the same as a vertical translation up. A reflection across the x-axis is the same as a reflection across the y-axis. A rotation can be described by a vertical stretch and a vertical compression. As vertical stretch increases, the slope of the line becomes steeper. As the vertical stretch decreases, the slope of the line becomes less steep. Learn these transformation rules now because they will be used again when we discuss transformations of quadratic functions and transformations of exponential functions in later units. And even beyond this, you're going to be doing a lot of this in Algebra 2. So if you get it down now, that's less that you have to worry about later on. So let's take a look at an example and identify some of the transformations. So for this one, I'd like to start from left to right. We've got a minus sign out in front, so that tells us we're reflected across the x-axis. And then we have the plus 5 in there, which tells us we're translated left 5 units. In this one, we have a 2/3 out in front, so that tells us that we have a vertical compression of 2/3. And then the minus 4 is not within a parentheses, so this is a translation down 4 units. 1/2 tells us that we are compressed by 1/2, and then the -7 in the parentheses tells us that we're translated right 7 units. For D, we have a 2 out in front, so we have a vertical stretch of 2, a +1 within the parentheses, which tells us that we're translated left 1 unit, and then a -10 on the end, which tells us we're translated down 10 units. In E, we have a minus sign out in front, so that tells us we're reflected across the x-axis. The 4 tells us that we are stretched, and then the -3 within the parentheses tells us that we have a translation right, 3 units. And then finally, this one, we have a minus out in front, so we're reflected across the x-axis. Now be careful here. We do have a fraction, 4/3, but that fraction is greater than 1. So you can't just look for a fraction and say, oh, I've got a compression. Because this fraction is greater than 1, you have a vertical stretch of 4/3. And then finally, the -3 on the end, not in the parentheses, so we're translated down 3 units. Now let's talk about describing transformations from a graph. To describe transformations when looking at a graph, identify the slope and the y-intercept. If the slope is negative, the graph is reflected across the x-axis. If the slope is greater than 1, the graph is stretched by the value of the slope. If the slope is less than 1, the graph is compressed by the value of the slope. The y-intercept indicates if the graph is translated up or down. When describing transformations from a graph, we are not going to be concerned with transformations to the left or to the right. So identify the transformations that took place from the thin linear parent function to the thick linear function. Okay, so the thin linear function in these graphs is going to be our parent function. That's what we're going from. So this is our reference, and we're going to the thick one. Okay, so let's start off by taking a look at our line. It is still increasing, so therefore we are not reflected. Our slope is up 2 over 1, so our slope is 2, which means we have a vertical stretch of 2, and our y-intercept is -2, so we're translated down 2 units. For B, we have an increasing line still, so we're not reflected. Our slope is 1 over 3, so we are compressed by 1/3, and our y-intercept is 1, so we're translated up 1 unit. For C here, we are decreasing, so we are reflected across the x-axis, and our slope is 1, so we are not stretched or compressed. Our y-intercept is -1, so we're translated down 1 unit. And then finally, we have another one that is reflected across the x-axis because we are now decreasing. Our slope is 1 over 2, so we are compressed by 1/2, and our y-intercept is -3, so we are translated down 3 units.
Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.